No. So last week we looked at what is needed when you are um, setting or what makes requirements document a good document. What are the features of good requirements? So I won't go through that, but as I said, this presentation will have a little bit of what we did last week, so we can move faster. But what I want to focus on this week itself is the document, exactly how the document should look. All right. This would have been in the slides that we looked at last week, non-functional requirements, the classifications that include their product requirements, the organizational requirements, and external requirements. So in the requirements, you have in your requirements document, first of all, there are two sets of requirements. You have your functional requirements and you have your non-functional requirements. And remember, we said that requirements have to be traceable. And generally, you have what are called user requirements, and then below it, we have the requirement specification, where we go into more details as to how what the specific requirements are within that user requirement, because users speak quite broad. Now, what the analyst does is to break down that broad statement that the user makes and create from that a specific set of requirements, which are the requirement specification for each user requirement. So that aside for the functional. We now have the non-functional requirements. And within the non-functional requirements, there are different types. Product requirements, organizational requirements, and external. And the product requirements now speak to the software itself, or restrictions or specifications about the software that cannot change. All right? It specifies the way that the delivered product must behave. And we mentioned this last week in terms of speed, reliability. It could be operating system. It could be a number of things, but these are specific to the software. All right. It could also include the data requirements, or I should say the RAM size, or the size of the software itself. Okay, so those are product requirements. They're specific to what you are developing itself. Now, organizational requirements. Is my phone still making noise? I thought I turned it off. All right. So the organizational requirements will affect the product that you are developing. Each organization has a particular way or style of developing the software that they produce, or it may have a particular look. All right. If you think about it, all Windows-based software or all software developed, for example, Microsoft, have a particular look. You can basically look at any software and say, oh, Microsoft developed this, because it looks a certain way. And those would fall under organizational requirements. So there are a consequence of organizational policies, procedures, process standards, use and implementation requirements. Anything that is specified by the development organization or the organization that is purchasing the software. They too may have certain specifics. For example, if you were developing software for Coca-Cola, that's a very popular brand, you know that the logo would have to be there, and they may have specifics about where the logo is placed. They would have specifics about the colors, because not all red is the same thing. So they would have specifics about the shade of red and the shape of the logo itself. And even closer to home, here at UTech, we have certain standards here as well. For example, if you look at all of our printed material, the UTEC crest has to be in the upper left-hand corner. No matter what you're doing, that is where it is. It is not placed anywhere else. If it is external to the university, there's somebody else. For example, if UWI is doing a flyer and it is their flyer, but UTEC is somehow participating or supporting, then the UTEC logo is going to be elsewhere. But if it is a UTEC document, our logo has to be in the upper left-hand corner. All right. And you will see that in most companies, their logo is always in the upper left-hand corner. So these things are what you call organizational requirements. And they're specific to the company that is purchasing the software. And depending on the type of software, it may also be specific to the company that is developing the software. All right. Now that is dependent on whether or not this is bespoke software, meaning that you're being paid to develop the software for a particular client, or if it is that you as a software developer is making software for the general public to purchase, then that will say what the organizational requirements are. Now, external requirements, those arise from factors which are external to the system and its development process, such as interoperability requirements, legislative requirements, so things that include how you handle data, security, all of these things that may be standards or requirements that are policy, national policy. All right, because we have to protect persons' data. We have to ensure that software interact with each other safely, that one software doesn't override the actions of another software in another environment. So there are certain requirements there. So those would count as external. How the software that you are developing behaves in relation to other software. So those are your non-functional classifications. Now, always remember that non-functional requirements can cause your software to not work or to be inoperable. So they're very important. And you have to pay a lot of attention to them. All right, I know we did go through this. So we have the three different types of non-functional: your product, your organizational, and your external requirements. Won't go through these too much anymore, but you can, because I'm sure you have gone through it already. Okay. All right. Non-functional requirements may be very difficult to state precisely, and imprecise requirements may be difficult to verify. Now, part of what we'll be doing this week is validation and verification. So, and for every requirement that is in the document, you have to have a way of verifying that it covers, that it is included in the requirements document and it is clearly stated. So let's look at some, continuing with this. A goal is a general intention of the user, such as ease of use. So that is something that you're aiming at. Now, how can you determine the ease of use? So a verifiable non-functional requirement is one that a statement that allows for some way of measuring this objective. A statement using some measure that can be objectively tested. Goals are helpful to developers as they convey the intention of the system to the users. That needs to be changed down here. Okay. All right, so here are some metrics, and I did run through this quickly. Speed, size, ease of use, reliability, robustness, portability. Now, for all of these properties, there should be a way of measuring each of these properties, and the measures are listed here. All right, for in terms of ease of use, I talk about the training time, how fast it is somebody can learn the software and get up to speed well enough to be able to use it. Okay. All right, and then there are some key points, and we can skip over those and move on to the software requirements document. However, before I start that, do I have any questions? Excuse me just a minute. Okay. All right, sorry about that. We're just trying to wrap up on your grades. I hope you have all been seeing your grades. Yes, no? All right. Now the requirements document. So you know what are functional and non-functional requirements, you know the features, all of that. So how do you assemble this? There are different types of requirements documents, and I think we're going to be looking at two. But just to say, whichever type you choose, stick to it throughout. Don't switch between standards. All right, the requirements document is the official statement of what is required of the system developers and should include both a definition of the user requirements and specification of system requirements. What it is not is a design document. All right? It should set out what the system should do rather than how. So your requirements document is not a technical document per se, because your client should be able to read it and understand it. It says exactly what it is that you interpreted from the client or the user of the system as to what the software should do. The how is the hidden part. That is left to the designer and the programmer. Okay, it's not something that the client needs to see. Now, it's not stated in this document. Yes?
Miss, would it be somewhat of a contract that the client would like sign off on?
Yes, because when the client reads through that document or when the client is given a presentation of that document, they're able to say, yes, this is what I want, and they approve it. And then from there, the software designers can now take it and do their modeling and development of the software. If it is that the client sees the document and they recognize that some of the requirements, they did not meet them, or they have decided that some should not be there or they need more, then they can make their comments at that time and a correction or a modification can be done. All right? So it is not a design document. Okay, but however, that said, this requirements document is taken by the developer or the designer to create the design document. Okay. All right, so users of the requirements document, these are your users here, your system customers, your managers, your engineers, your test engineers, and your maintenance engineers. I think we did a run through these briefly last week. So your customers, these are the ones who are paying for it. Okay? These are the ones who are purchasing the software. They specify what it is that they want. They specify the requirements and they read them to check if they meet their needs. Customers specify changes to the requirements. The managers use the requirements document that is the managers of the software development company. They use that document now to say, this is what I am going to charge you to develop the software. So they use the requirements itself to determine the cost of the system, and they can use it to plan their bid for the job. Okay, it can be if it is a case where the software is not specifically for any one client, but general software that will be placed on the market. The system customer would be persons who would respond to the development company's surveys, and they would be able to develop their requirements document from the feedback of the surveys. And the managers now would use that feedback that is used to develop the requirements document, and from that they should be able to price the software. They have a pre-release price, or they can project what kind of price they're going to charge the public for the software when somebody goes to download the software. All right, so they say annually you pay X, Y, and Z. They can plan. They can use that price now to say, okay, if I can sell this, how many copies of it, this is what I will make, this is what it will mean for my company. All right, so that is what the requirements document does. Now, the system engineers, on the other hand, use a requirement document to understand what it is that they need to develop. And they use that also in the planning of the how it is going to be developed. Okay. And when we get to modeling, you will understand how the system engineers use it. Because it's really interesting. You have different types of models, and based on the requirements that are in the requirements document, you might want to use a particular modeling type than another one. Okay. And the test engineers know they use the requirements to validate, to develop methods of validating the system itself. So in the requirements, you'll have a list of wants. So the test engineers will go and say, okay, the software should do X, it should do Y, it should do Z. How do I test for X, Y, and Z when the program is developed? That is what the system test engineers do. They use the requirements to develop validation tests for the system. The maintenance engineers use the requirements to understand the system and the relationship between its parts. So they know that one requirement is leads to something else or something else. So you can see the different sections of the software system itself based on the requirements. Because the requirements would have been written in such a way that it could be in units or in different parts. So the system engineer is able to see what each unit of the software should do or how it behaves. All right, requirements document variability. Information in requirements document depends on the type of system and the approach to the development used. Systems developed incrementally will typically have less detail in the requirements document. Now, you remember last week this question was asked for agile systems or incrementally developed systems? I think it was you, Mr. Johnson, who asked that question. Or was it Mr. Stewart? No?
And I had something relating to it. There was someone else.
Okay. But somebody had asked how you develop a requirements document if you use.
I did.
Yes. Yes, I think yes, it was you. All right. So as it says, if it is incrementally developed, it will have less detail. And that is because you develop one part, one increment, and it meets a particular set of requirements. That's done. Move on to the other increment, which would have a different set of requirements. So and these would be quite general. Because as you develop incrementally, you will see the features coming out a lot more. So it won't have as much detail as if you had just sat down and discussed it and say, I want. Incremental development, you want, but there are other things put in there as well. And you're able to, therefore, at that time say, no, take this out or add that in. So it makes it a little bit easier and the document a little bit smaller. All right. Requirements document standards have been designed using, we use the IEEE standard. And these are mostly applicable to the requirements for large engineering projects. But for small projects as well, it does work. The standards are fairly simple, very straightforward, easy to follow. Okay. And we did go through those last week, didn't we? Yes? No? You're all seeing me, you're still not talking to me. Has everybody gone?
No, miss.
No, miss, we're still here.
I'm here listening to you.
Okay. All right. All right, so this is one example of the structure of the requirements document. Very straightforward. The chapters include the preface, the introduction, glossary of terms, user requirements, definitions, systems, architecture, the requirements, specification, models, evolution, appendices, and indices. All right. Now let's run through this. The preface or preface, as some people say it, defines the expected readership of the document, its version history, including a rationale for the creation of a new version, and a summary of changes if there was a previous version. I'm not gonna read through all of these, but you can go through it. Now the introduction is one chapter that defines more specifically what the how should I put it now? The scope of the software, right? It is very important because if you're going to do software development, sometimes or any kind of the project or research at all, you can get sidetracked. And you can, while you are doing your work, you realize that, oh, something else interesting is there. I could do that. I could explore it. But what the introduction does is define exact boundaries so that you don't go outside of those boundaries, no matter how interesting it is. All right? So in the introduction, it describes the need for the system, Briefly describe the system functions and explain how it will work with other systems. It should also describe how the system fits into the overall business or strategic objectives of the organization commissioning the software. All right, now all of this is brief. You see where it says briefly describe the system's function and explain how it works with other systems? That is setting the scope, the boundaries of the software itself, so that we all, the purchasers of the software or the clients and the developers, clearly understand what is supposed to be done. Okay, within those boundaries, there are many things that will be done, but you don't go outside of those boundaries. Certain terms will be used in the development of the document. So of course you use your glossary. There might be acronyms that you use in terms of the organization, certain organization specific acronyms. All of those are put in there. If it's an industry-specific software, there are certain terms used in industry that might not be used by the general public. You put those in there. So it defines the technical terms used in the document. Then you have the requirements definition. Now note, what we're going through is the requirements document, not just the requirements definition. The requirements document. So it does include the definition. It also includes systems architecture. So it presents a high-level overview of the anticipated systems architecture. And typically these will be your non-functional requirements, or will be a part of your non-functional requirements. All right, are you still with me?
Yes, miss. I have a quick question. So, this is basically what we're submitting as a project, the requirements document.
That's right. Is
Okay.
my video frozen?
Yes, miss.
Yes.
Okay. All right, that's why I wondered if you were still with me. I saw the video looking frozen. See, this is why I don't want to be on camera. But anyway. All right, continuing. You have your requirement specification, and that is where you go into the details of the user requirements and what the difference. So you take each user requirements and you go into the specifics, the specific requirements for each of those user requirements. Okay. You describe the functional and non-functional requirements in more detail. Okay, and interfaces to other systems may be defined. System models may include, and notice it says may include, graphical system models showing the relationship between the system components and its environment. Examples of possible models are object models or data flow models. No, it says may include. The requirements document, if I ask you to develop the requirements document, I need to see system models. Not all clients need to see it. However, there are some models that are not as technical as others, and because they're graphical, it is easy for the client to see how the software will work in practice. So they are useful. There are some system models that are a little bit more technical than others, and so you have to know which one to use and when. All right. But for me, I need to see system models. Technical or graphical doesn't matter. I need to see it.
Ms. Chambers,
Yes, sir.
one more quick question.
Mhm.
In regards to this, the requirements document, in a real world scenario, is this after you have gotten the project, or is this something you would do in bidding for the project?
All right, this kind of detail would be after. So where you would probably stop in bidding for the job would be at the user requirement definition. All right, because that is telling you what it is. You are saying, from what the broad statement that you're made, this is how I interpret it. Okay, if you notice, the user requirements are what are used to develop the system requirements, which are a whole lot more detailed. And I would not go into the system requirements at the bid stage. I would just stick to the user requirements.
Thanks, sir.
Okay. All right, now the system evolution should describe the fundamental assumptions on which the system is based, any anticipated changes due to hardware evolution, changing user needs. This section is useful for system designers as it may help them avoid design decisions that would constrain likely future changes to the system. So what this tells you is if it is that the software is to be used in another environment with other hardware, then it says how the software should behave, or some assumptions that, not even how it should behave, but some assumptions that are necessary in when you need to make these changes. Okay. For example, if it is that you are developing the software based on a particular set of non-functional requirements in terms of speed, reliability, memory, that sort of thing, then as the system evolves, if there is going to be evolution, meaning that you need to increase the data input, or your system will be using more data, then you can state then that these will be the likely requirements based on an increase of data. So that is an example of what this is. Okay. Your appendices should provide in detail information as it relates to the application being developed, hardware and database description, and database requirements, define the logical organization of the data used by the system and the relationships between the data. And also, for my document, the appendices should also include a work plan. And your indices is just, well, you know what indices are. Alphabetic, and they give the page numbers to particular headings, functions, diagrams, all of that. All right, it just makes it easier because your requirements document may turn out to be fairly large. So the indices make it easier to find what you need to find when you need to find it. Probably much faster than the table of contents. And that is not included here. Table of contents need to be included as well. All right, so that is one structure. Now, this is a second structure. They tend to be fairly similar, but just how it is laid out is slightly different. In example 2, you have your introduction, overall description, specific requirements, and supporting information. And under those 4 broad chapters, you have some bullets here that you need to address. So in your introduction, just as I discussed before, you have a scope, but you also include the purpose. You also have your definitions, acronyms, and abbreviations, which would be in the glossary in the other one. That is found in the introduction. Your references and your overview. So all that would be in your introduction. Then you have your overall description, which is product's perspective, functions, user characteristics, constraints, assumptions, and dependencies. Okay, no questions then. Then you have your specific requirements, your external interfaces, functional requirements, performance requirements, database requirements, design constraints, software system attributes, and any additional comments. And then lastly, you have your table of contents and indices and appendices. I would, though, if you're using this, I would put the table of contents before the introduction. You know how you're laying out the document. So you have your cover page with title and all of that. Then you go straight into your table of contents. Then you have your introduction and so on. Any questions on this one? Or any comments? Looking at this, which one would you prefer to use?
First one.
Why, Mr. Johnson? Yes, why? Why the first one? Mr. Rainford says less clutter. Do you agree with that? Anybody else?
It looks
It looks more straightforward, the first one, doesn't it? More organized. But the second one gives you a little bit more freedom. Don't you think? All right, sorry about that. My door is open, so I tend to have visitors. All right, now your requirement specification. And no questions on the format? Everybody's fine? Let's see what Mr. Rainford said. Yes, Mr. Rainford, I'm in my office. All right, so we can continue then. Requirement specifications, as I said earlier on, they're an expansion of the user requirements. The process of writing down the user and system requirements in a document. The user requirements have to be understandable by end users and customers who don't have a technical background. But the requirements specification now details it a little bit more. System requirements are more detailed and may include technical information. The requirements may be a part of the contract for the system development It is therefore important that these are as complete as possible. Now, when you are bidding on a job, generally speaking, it would be the user requirements that you have there. The system requirements, though, or the requirements specifications, even though they are done, may not be in that bid document. And why that is so, even though you develop them and you use them to bid for the job, you have to be careful, because if you give these a number of your specifications, requirement specifications, those would be based on how your company or your systems analyst understands the user requirement. And that is a part of the work, that is a part of the intellectual property of the design company, the software development company. And if you're bidding on a job, you don't really want to be presenting that work and not be sure that you are going to get the contract. Because once you make a bid, that bid document goes to the client or the prospective client, and it is not coming back to you. And they're free to use it as they want. So they may take it and choose their friend or a very cheap contractor and say, okay, I know this is what you said, but this is what another company wants to do, and therefore I'm giving you the job, this is what you should do. And that is morally incorrect. So you don't tempt persons by doing that. Any comments here? None. Seriously, none? Everybody understands what I mean by that?
Yes, man. Very good, really.
Okay, all right. Now, when you're writing your requirement specification, this should be done in natural language. The requirements are written using numbered sentences in natural language. Each sentence should express one requirement. Now, there are two things here. You remember last week, I can't search for it and find it now, but I'm quite sure you can, where you saw the user requirement and below it, the list of specifications from that user requirement. Now, if you note, the user requirement was numbered. I think it was number 1, requirement 1. And then the specific, the specifications, there were about 3 or 4, and it was like 1.1, 1.2, 1.3, 1.4. And you can even have 1.11, 1.12, and all relate to user requirement 1. So it's numbered. Okay. Now, each sentence should express one requirement. You know, that's a very hard thing for us to do. If I ask, if I take a look at any of the work that you've done so far, any of your academic writing submissions, any of your lab reports, I am quite sure that I will find sentences in there that say 2 things instead of 1. Isn't that true? We like to group things together. Now, as engineers, one of the toughest things for us to do, but we must do, is to say one thing at a time. Each sentence must address one thing. And as much as possible, each paragraph should address one idea. So we have to learn how to write things clearly so that you know when you finish that paragraph, you have discussed everything about that particular idea. When you finish that sentence, you address one particular aspect of that idea, just one thing. So you don't say the software should add and multiply, add two numbers and multiply two numbers. Or it should add two numbers and output the result. No, it should say software should add two numbers. Software should output the result of the summation. Two different things. Each sentence does one specifies one requirement. Any comments there? Everybody clear with that?
Yes, Doc. Clear.
Okay. Oops, what am I doing? All right. So we're using structured natural language. The requirements are written in natural language on a standard form or template. Each field provides information about an aspect of the requirement, and you can utilize whatever template you want to. All right. Graphical models supplemented by text annotations are used to define functional requirements of a system. I am not doing UML or Unified Modeling Language with you because this is just an introduction, but you can use UML and sequence diagrams. I will be looking at sequence diagrams shortly. I think by next week we'll get into those. All right. And the thing about graphics is that they say in one graphic what 2-3 pages will say. So they're very useful. And we always understand pictures a whole lot faster than we understand words. Isn't that so? Now, as engineers, we love math, don't we? Yes? You agree with me? No, nobody agrees with me. So as much as possible, use mathematical notation. Because with mathematical notation, you don't make mistakes. The ambiguity that you can get in when you use words are removed whenever you use math. These notations are based on mathematical concepts. Although these are unambiguous and can reduce ambiguity in a document, most customers though don't understand formal specification and are reluctant to accept it as a system contract. So mathematical notation, I like because I'm an engineer. It is straightforward. You can see it as a technical individual. You can see it and understand it. But the client will not or may not unless they're technical persons. But regardless, they may not want that in their requirements specification or their requirements document. However, when it comes to the designer, the system designer, the mathematical notation is quite useful. So I personally like to see mathematical notation being used. But the customer themselves may not ask for it, may not want it, but that's fine. All right. Requirements are written as natural language sentences supplemented by diagrams and tables. And it's used for writing requirements because it is expressive, intuitive, and universal, meaning that everybody will understand it. Okay. Now here we have some guidelines for writing your requirements. We went through two formats, but notice this says invent a standard format and use it for all requirements. So I showed you two examples. And you see that in both examples, there are certain items or certain things that are required that must be in there. The organization is somewhat different. but you can choose to invent your own format as long as you are consistent and as long as everything that needs to be in a requirements document is there. Your user requirement, your specifications, your functional, non-functional requirements, your introduction. I should have started there with a scope or boundaries of the software. Your appendices should be there. All right. So you know, you have an idea of what is required and you can develop your own format. No problem. I will not penalize you if you don't have the format exactly as laid out in these two. If you notice, I gave you a breakdown of what I expect to be in your document. And I also gave you a rubric, didn't I? At the back of the document, didn't I say which section, the value in terms of marks for each section? Am I talking to myself?
Miss,
Yes, Ms. Montague.
I kind of lost connection with you for a minute there. Could you repeat what you said, like the end part?
All right. I'm saying to you that in the assignment that I gave you, at the last page, I think it was, I gave a breakdown of the marks for the assignment. Did I? Or didn't I?
Yes, miss, there is a breakdown.
Okay. So there you go. You can use that. I've given you an idea of what must be in your requirements document.
Yeah, that is clear.
Okay.
There's something about code though. Wanted to ask you about it. You said we weren't going to write any code.
You're not writing any code, but if you have code, that is the format that you should put it in. There is no grade associated specifically with code. There's a grade for format, and code is under that. It's just a look, how it should look if you include it. All right. Use language in a consistent way. And again, we did discuss this last week. If we use start, stop, don't write start and stop somewhere else. Use shall, and this is, you know, you might say I'm spitting hairs here. Use the word shall for mandatory requirements. If it must be in there, use the word shall, don't use must. This shall be, all right? If it is that is something that you would like, but it's not a must, then you use should. Should for desirable requirements. All right, so shall for mandatory and should for desirable. Desirable requirements are good if they're there. If they're not there, that's okay as well. Use text highlighting to identify key parts of the requirement. And avoid using computer jargon, because remember that this document is also supposed to be available for it's supposed to be readable by the customer. And if you put computer jargon in there, they can get upset that you're trying to trick them with big words. Yeah, people like simplicity. They like simple words. So as much as possible, stick to the simple words. Don't put the jargon in there. Leave that for the specification to the designer. All right. Include an explanation of why a requirement is necessary.
Can you give us an example of the jargons you're referring to?
No, this one I'm not quite so sure about. What are the different, do you remember the different names of the different Android releases. I know there was a KitKat. I don't know where we are now.
Oh, Lollipop.
Yeah. Now, if you put that in a document, you know,
Lollipop was one.
if you put that in a
KitKat.
document for the client, they will have no idea what you're talking about. Those are names for the different Android releases, but then it is easier if you put Android release such and such. They know exactly what you're talking about. Just anything specific to computing, any technical terms at all, you avoid that in your requirements document that you will be sharing with your user or your client. Okay. No, even though we're using natural language, there are problems with it. As I said before, graphics work, mathematical notations work. And the reason why they work is because they're not ambiguous. They're straightforward, they're clear. Natural language, the way we speak, can sometimes be not too clear. What I will say and intend to mean a particular way, you may hear and you hear it the way you want to hear it and you interpret it another way. So the problem with natural language is that precision is difficult without making the document difficult to read. Meaning that sometimes when you're trying to explain some things, you have to write so much just to ensure that you're so clear. It makes the document big. It makes it hard to read. So that itself is a problem. And learning how to speak in simple, or not just speak and write in very simple ways that get your message across is a hard thing for us to do, isn't it? Particularly the more educated you are. And it should be the opposite way. I remember when I just started doing my PhD, I had to write a report. The first report that I had to write for my supervisor, within the first month, he said, no, the first day I went, first meeting, he gave me a report to write. And he said, don't come back to me until you've written this report. But he wants it within 2 weeks. I wrote my report, and my report was wonderful. I gave it to him, and I got it back the following day. And I've never seen so much red ink in all my life. And you know why that was so? He sat me down and he said to me, and in a way that was not, how should I put it, that would not hurt my feelings. He said to me, he asked me, why is it that Caribbean people like to use such big words? Why can't you just use the simplest words to describe what you want to say? So as much as possible, don't use big words. Big words can get you into problems. Be very clear, be very specific with what you're saying in as short a sentence as possible. That was the other thing. He cut out chunks of my sentences because he said that that was padding, unnecessary padding. Nobody wants to read it. And that is true. If you make a submission to me with too many words, chances are I am not going to read it. I don't have that kind of time or interest. Get straight to the point. Don't add too many words. Don't stray off topic. Okay? It will be one of the hardest things for you to do, to keep it simple, but it's something that as engineers, you have to learn to do. Not a lot of words. I think the term that we use for persons who like to use lots of words, lots of big words, is verbose. Even that is too big a word. All right. Another problem is requirements confusion. The mix-up between functional and non-functional requirements. Tell me, what is the difference between functional and non-functional requirements? Should I pick on somebody? Or will somebody volunteer that answer? Miss Henry, you're very quiet. Do you have a microphone?
Yes, miss.
Okay. What is the difference between functional and non-functional requirements?
I think functional actually outline what is actually required, while non-functional is more ambiguous.
Not really. You're almost there, but not really. Anybody else I can pick on? Or anybody else willing to volunteer? Mr. Clark? Marcelo? I think that's his surname. Oh, not there. All right.
Yes, miss.
Yes. Go ahead.
Yeah. Oh, he beat me. That's fine.
No, man, you can't go ahead. God was listening in.
No, I've answered your question. What's the difference between functional and non-functional requirements?
Still analyzing this.
Okay. And anybody wants to volunteer the answer?
So I think the non-functional requirements are the, what should I say now, the criteria used to judge the operation of a system. And the requirements, the dedicated requirements now is, you know, the cornerstone the system needs.
All right. You know, I think I know what you're saying, Mr. Clark, Richard Clark, but you're doing just what I told you not to do. Big words. Very simple. Keep it very simple.
My apologies.
Functional requirements are requirements that actually do something. Functional requirements describe what the system does. They're doing. Okay? Non-functional requirements are constraints. They don't do things, but they restrict your system. Okay? Everybody clear with that now?
Yes, miss.
Okay, good.
Crystal.
Very good. The requirements amalgamation. Remember, I was just talking to you about that in terms of sentences, trying to say more than, or saying more than one thing in one sentence. That is a problem with natural language. Several requirements may be expressed together. You have to be careful about that. All right? One thing at a time. All right. Structured specification. Let me just check how many more pages we have because I'm going slower than I thought. But okay, I'm all right. But time. Oh my goodness. What happened there? Goes right back to the beginning. All right. Structured specification speaks to the freedom of requirements. Freedom of the requirements writer is limited and the requirements are written in a standard way. So based on what I was telling you before, where you are free to choose how you want to write your requirement specification, you can go ahead and do that. However, if you're asked to use a structured specification, then you don't have that freedom. Okay. It works well for some types of requirements, but is sometimes too rigid for writing business systems requirements. So sometimes you're not able, based on the structured specifications, you're not able to capture everything that the user actually wants within that format. All right, but it is very clear. It is very easy to understand your requirements when you write it that way. Your form-based requirements, now you have the definition of a function or entity, and we're going to be looking at entities later on down, so just hold that word and we'll come back to it. It has a description of inputs and where they come from, description of outputs and where they go, information about the information needed for the computation and other entities used, description of the action to be taken, pre and post conditions, and side effects. Now, this particular type of specification lends itself to a particular type of system model. And I want you to bear this in mind because we're going to come back to it. All right, the form-based type of specification. Because when you specify based on this method, your function, your inputs, outputs, information needed for computation, actions to be taken, pre and post condition, and side effects, there is a specific system model that deals with this type of specification. All right, so the structured, where am I? So why isn't it coming up? I'm going to have to put that one in. It's not there. My apologies. I will put back slide 2 and upload it to you. All right. Tabular specification uses is used to supplement natural language, and it is useful when you have to define a number of possible alternative courses of action. The example that we use here is one that you're quite familiar with, your quadratic equation, and your different conditions: a equals 0, b squared minus 4ac less than 0, equal to 0, greater than 0. Now, for each of these, you would take different actions, or the method that you would use to determine the result would be different. So in a situation like this, remember, you are not writing pseudocode, you are not drawing a flowchart, you're not writing code. This is a specification. If this happens, that is what you do. So you put it in a tabular form. So it makes it very easy to see. All right. Remember, this is not technical. If you were going to be technical, then you could use a system model to represent this. You could use a flow chart. You could write this quite easily in code, couldn't you? But for a user or a customer to understand the specification, this format is a lot simpler and a lot more obvious and easy to understand. Am I right or am I wrong? Okay. Today's designated talker is not here. All right, don't forget that one. All right, so the requirements engineering process, you have your elicitation, analysis, validation, and management. And it is iterative. So you generally go from one to the next, but you can always go back and repeat until you ensure that you get the right requirements document. All right. This is a spiral view of the requirements engineering process. You start out, you have your business requirements specification, your feasibility, your requirements elicitation, user requirements, prototyping, system elicitation, system specification and modeling, then reviews. But look at it. This spiral is broken up into 3 quadrants. So basically, you're doing the same thing over and over again. Your elicitation, your specification, your validation. And then from your validation, you're going to have to go back and elicit more information, specify again, and you keep going. Generally, that is how it works. Yes, we have, you might say it takes the form just like the development process. The requirement process can take the waterfall, the format of the waterfall method, but it doesn't, because you generally have to keep going back to ask questions to ensure that you get the requirements right. Remember that the requirements engineering part of the software development is just one aspect within the waterfall process. Okay? Okay. All right. So the elicitation now. I forgot that it was briefly mentioned in here. Sometimes the elicitation is called requirements discovery. It involves technical staff working with customers to find out about the application domain, the services that the system should provide, and the system's operational constraints. They involve end users, managers, engineers, domain experts, trade unions, and all these are called stakeholders. I went through that pretty fast because I want to stop and explain it now. Requirements elicitation. When you are bidding on the job or when you are going to develop software, you are given a general idea of what it is that is required. What requirements elicitation does is to allow you, the developer or the analyst, to go to the client, the customer, and the prospective user to find out what it is that they want in the software. So you see, it may involve end users and managers. However, you have people like the engineers involved in maintenance. These are the customer's engineers, the persons who will be installing the systems, the person who will be updating the system, the persons who will be doing the day-to-day, giving the day-to-day feedback or the day-to-day troubleshooting or correction. These persons will have certain requirements. They will say, I want to be able to do this, or I want the system to be able to do this. All right. Domain experts, when we talk about domain experts, is the area within the software, within which the software is going to be used. If it is going to be used in a pharmacy, then pharmacists or persons working in the pharmacy would be the ones, or persons who know about how a pharmacy works. Those experts would have to be spoken to. You have to elicit some requirements from them. If it's a bank, your personal bankers, your private, your tellers, all of these people are persons who understand how a bank is supposed to operate. These are your domain experts. Then you have your trade unions. And these are, you might say, but we're developing software. Where do trade unions, or how does a trade union come into this? There was a time where, and there are some people who still believe that computers are taking away people's jobs. And if you are developing a software that will basically eliminate the role of a particular individual in the organization, then the trade union is going to get upset. So consulting the union on how it is that these persons within the company operate is necessary. It may be that you're going to have to tell the or the trade union is going to have to understand that persons may have to retool, meaning that they have to get educated to take on different roles in the organizations, or it may call for an expansion in the role of the individual. The trade union has to understand this and can and should be able to talk to their clients. All right, there should be no development in an organization that has a trade union and the trade union is not spoken to. All of these persons come under one general name, which is stakeholders, because everybody has a stake in the development of the software. Everybody has an input. Everybody is affected by the development of the software. All right, so they're stakeholders. Problems with the requirements analysis: stakeholders don't know what they really want. And it's funny. We all want development. And sometimes when we hear about what development may lead to, we don't want it. So we really don't know what we want. We want to stay right where we are and get everything that we want to get without realizing that there will be change. And nobody likes change. So this is something that it is hard to talk to your stakeholders to get from them what they want, but you have to sit there and you have to watch them in what they do and speak to them to see how it is they want the software to help them to do their job better. Stakeholders express requirements in their own terms. So the end user will say, I want to be able to do this based on the job that they do. However, the management staff now will express their requirements at a higher level because they are not looking at the day-to-day operations. So, and you can't even ask them about day-to-day operations because they truly don't know. All right, so it is the end user at the bottom who would have certain details, who would know certain details. A good practice in business, though, is that if you're going to be a manager of a company, you really should start at the bottom. Even if you're employed as a manager, you really should spend a few weeks at each level to understand exactly what happens there. A lot of persons don't do that anymore, but it's the way that it should be done. All right. Different stakeholders may have conflicting requirements. I'm quite sure management requirements would be entirely different from trade union requirements. Now, you remember, was it last week or the week? Yeah, last week when we spoke about ranking the requirements in terms of importance. Yeah, you have to see who is the most important one and rank the requirements accordingly. Organization and political factors may influence the system requirements. And when we talk about politics here, not external politics, it could be politics local to the organization. External politics can affect it as well, but for this example, we're speaking about within the organization itself. All right? What that means is that a particular role a person in a particular role might want to define that role as being more important than somebody else's role. So it means, therefore, that the software should be skewed to that particular role and not towards the other. So you have to understand the political wranglings within the organization itself, right? But bear in mind, the software that you're developing has to carry out the role, the broad role that you were given originally. What you're doing here is narrowing it down to, or not narrowing it down, but identifying all the smaller requirements that will make the software what it should be. The requirements change during the analysis process. New stakeholders may emerge and the business environment may change. So new people will come in and say, hang on, I was not consulted. I need to be consulted on what happens here. All right, so as you go along, more people may be included, or the focus of the organization that you're developing the software for may change. It doesn't mean that they're no longer going to need the software, but they may just need how or what it is that the software should do to change. And you should be able to capture all of that. I am rambling on and nobody's asking me anything. Remember, you'll be tested on this weekend. All right. Requirements, elicitation, and analysis stages. So you have your requirements discovery and your requirements classification and organization. Let's start off with those. Your discovery is interacting with the stakeholders to discover their requirements. Domain requirements are also discovered at this stage. When we say domain, we're talking about the general environment within our field within which the software is supposed to operate. Okay. Also, with interacting with stakeholders, it doesn't always mean that you're going to sit and have a conversation with people. That interaction could be just sitting and watching. You watch how the company does its work so that you can see what to include in your requirements document. Okay. Then you have your classification and organization. You group requirements that are related together and organize them into coherent clusters. So you have certain areas of certain requirements that relate to a particular aspect of the software. Another set of requirements relate to the another aspect of the software. So when you're writing your requirements document, you don't jumble everything up. You deal with one set of requirements that relate to each other, then you move on to another set that relate to each other. It makes much easier reading. And I do believe that's where we end today. Any questions here?
Miss, all of this is going to be on the test on Saturday?
Yes,
like
Miss
from
Mantik.
where?
All of it.
Okay, Miss.
All right. But why are you so worried about that test?
Miss, I'm not worried, Miss. I'm just sure you don't.
A test is just a reflection of what you've learned. So if you've learned, you know it will reflect well.
Okay.
I have major project next week.
What about major project next week?
Book is due.
That doesn't have anything to do with software engineering. Software engineering is a level 3 module.
Well, I know.
Okay. Just putting that there. Okay. All right. Since nobody is asking anything about this, let me ask.
With the major project proposal, it's due on Monday now, so maybe that's why Mr. Lin was suggesting the test this weekend would be a bit of a challenge.
No, it's not going to be a bit of a challenge. Listen.
Repeat that for me, miss.
It is not going to be a bit of a challenge. What you have to understand, you have 5 tests to do. Well, 4 and a presentation. Yeah? Don't you think it's easier for me to give it in 4 tests than in 1 large test? This way you're able to handle it in smaller bites. Putting off a test like this, postponing a test like this is not going to make it easier. It's going to make it harder. All right?
Okay, miss. Majority ruling, so if no one else have any objections, that'll work.
No. Hold on. You made a mistake there, Mr. Sawyers. This is not a democracy. This is a dictator.
Okay, miss.
Thank you. Okay.
All right.
Miss, I have a question about the system requirements.
Yes.
Miss, is it that the clients like they come up with an idea of what they want first, and then they let the software companies know, and then like they kind of make the the requirements something?
Yes. All right. So I am in business, and I start out small, just me and two employees. I make my product, I have somebody who package it, and I have somebody who goes and sells it. Yeah. Then I get more customers. Now the person who is selling it have to develop my my website or my Instagram page or whatever online presence to get my product sold. I have my packager coming up with all sorts of different types of packaging. They have to source the packaging from somewhere, and I'm there in wherever I am manufacturing, making my items. Yeah. So that gets tough. So I employ more people. Now, when I employ more people, I now have to figure out how much did I say I was going to pay this person? Oh, but I have to send off his taxes. I have to do all of these deductions. Health plan. I have to sort out their health insurance. And what about life insurance or the indemnity for each of these employees? Because guess what? They're working around stoves here because I have somebody helping me. I could be printing things, so it may have carbon dust. I have to think about all sorts of things. So I say, you know what is true? I need a piece of software that can help me manage my business. So I put an ad out there for somebody to develop a piece of software that can track orders from or can receive and process orders and give instructions for shipping of these orders to my customers, but it should also handle the financial side of my organization as well. And I just say it like that. I tidy it up, put it in a newspaper ad, and that's it. Somebody who understands, a software developer who understands how a business is run, to say, hang on, based on what you said, this is what you need in terms of broad requirement statements. And they say, for that, I look at it and I say, yes, this is what I need. And the person says, well, for that, this is what I am going to charge. And that's how that is done. Now, okay. when I say, okay, I'll take that charge, I'll take that charge, and I sign the contract, then the software developer now comes with the requirements document that will look at each of those individual user requirements and write the specification, include functional and non-functional requirements, along with all of what else is needed to make this document easy to understand. All right.
Okay, thank you.
Yeah.
That was a very good example.
Okay, thank you. All right. So my question to you, how is the assignment going?
It's just another thing, you know. Well, for my group, we've met and kind of gone over like who should do what and the various stuff. And I had a few questions, but you explained them today during your presentation of this.
Okay,
So
wonderful.
that's
And
good.
that's why this is a semester long assignment. So you get it at the beginning so that you can see how it will develop right to the end. You don't just get it at the end and you say, oh, is what should you say about that and them time there? No, you go and you develop as we go along.
One question, Dr. Chambers.
Yes, Mr. Sawyers.
As you mentioned that we should develop using it should be an Android app. So we were wondering if that's one of the constraints that you place on the software that you.
Yes, it was a
Could it
definite.
be
It was an obvious constraint.
Okay.
All right. So that will tell you, and based on just me saying that, that is also going to tell you the applications of it, where it will work, what sort of hardware it is going to work on. It will also give you an idea of the general look of the software. So your graphical user interface there is restricted.
Okay, miss. Understood.
Okay. All right. Is there anyone here today who is not in a group? All right. So everybody's in a group. If you know of anybody else who is doing this module who is having issues with being in a group, please let me know.
Miss, I think Tandel Wilson was saying that he wasn't a part of it. I'm not sure if you found it.
Okay. All right. I make a note of that then. Is there anybody else? Or is there any group here that has under the 5 students? Is it 5 or 6, I said? Everybody's okay. All right. Well, if there are no more questions, I will if there are no more questions, I will pause here and we see each other on Thursday. Again, I say I'll upload these notes and the video recording of this session. My only problem now, I'm realizing that the video recording has to be processed. It means I'm going to have to sit at my desk for a while and wait. All right. Mr. Rainford, you had a couple of questions? No. Okay. All right. So if there are no more questions, well, we leave it here. Have yourselves a good evening.